13, we throw in the equal sign. And first thing is always, no matter what we're doing, we got to be in standard form. Now, standard form, as I said yesterday, takes on ax squared plus bx plus c. And with that standard form, sometimes it takes on just a slightly different meaning depending on what we're doing. Now that we have equations going on, standard form, you have to realize, has to be equal to 0. 13 does not, so we have to rearrange it, set it to 0, add 4. So set it to 0, add 4. As we add 4, we're going to combine it with the 20. So what we're really working with is this polynomial right here, 24, right? Now, you don't do anything different. Yesterday we didn't necessarily add in like a whole brand new type of factoring or anything like that. It was the same old we've been doing, our guess and check. It's a trinomial, and we list out our factors of a and c. So factors of 5 and factors of 24. Nothing was changing whatsoever. We were doing the exact same thing that we've been practiced on the previous week with. And A continues to build everything that we've been doing. But the one small thing now to not forget, because it starts off with an equation, starts off with an equal sign, we got to make sure we carry on that equals 0. We'll deal with that here in just a moment. But we keep doing the exact same thing. Now, what do we know about our signs? They're both the same. It's a plus plus because the linear term is positive. There's no negatives up there, so that is nice. And our goal is to get up to a what? 26. So this is all part of what we've been focusing on. That's what I'm going to check on today with you is, can you do the basics of factoring? All right, trying to get that up to a 26. You're trying to figure out, again, which pair on the C is going to work for you. And based off of what I'm seeing as the answer choice, it's going to have to be a 4 and a 6. And the 4 and the 6 combo is going to work. You always check your guess. And as we said, this is the combination I'm checking right there. 5 times 4, 20, 20, and a 6 is created here. That's where we're getting that 26 from. That's everything we've done up to yesterday. And then what did we do yesterday? We use what we call the zero product property. And the zero product property says, how does each quantity become 0? What does n have to be such that when you plug in for n, each quantity becomes 0? So the zero product property says, take each parentheses, and I'm running out of some room here, so I'm just going to take 5n plus 6 down here. You're going to set each quantity now that it's in factored form, you're going to set each quantity equal to 0. And you're going to solve out for n to get you 2 solutions, and that's telling me n has to be this specific number so that each quantity becomes 0. Here, it's pretty quick. You can tell me n has to be -4. Here, you got to solve out just a little bit more. You got to divide by 5, and n is -6/5. So what this again is telling us is n is these 2 solutions. If I plug in n back to here and here, if I take -4 and I plug that n in as -4, what that means is this quantity is going to become 0 here. Now this is not going to become 0 here. This is going to become what is -4. -20 plus 6 is what? -14. Now -14 times 0, that's going to make it balance. 0 equals 0, that equation's balanced. -4 works for that. And then the other thing that happens here is, the other number that does that for us is the -6/5. If you plug in -6/5 here, this quantity becomes 0. Now over here, this is some number. Whatever that number is, I don't care. 0 times that number is going to also make it balanced. That's going to become 0. That's where I'm getting those 2 solutions. That's what we did yesterday on this extra step right there. Now, all that to go back to number 16. Now number 16, as I take a look at those 2 solutions, we want to go backwards. We want to take the 2 solutions that we have and create this factored form right here. So I get a 0 solution, I get a negative 2/3 solution. How did I get that? Or what did the factored form have to be? And I'm going to use this negative 6/5 right here. I'm undoing everything that I had here. I'm undoing division. I want to set this thing back to 0. So to undo division, what do I have to have? I had to do multiplication. I had to have a 5n equals negative 6. And to get that thing back to 0, I had to undo subtraction. And to undo subtraction means I had to have addition. So when I come back here to x equals negative 2/3, to undo that division, that means I had to have originally multiplication. And to undo that subtraction, what did I have to have? I had to have addition. That's where I'm getting that 3x plus 2 quantity. And then you can always take it and say, hey, if I take that quantity and set it to 0, do I get that original solution? And I get negative 2/3. Now that other solution of x equals 0, that's going to be it. Okay, x is just going to be it. There's no other number there for us to move because it's already set to 0. So it's just going to be x. And then we're creating a factored equation there. So we're going to set that equal to just 0. Now, it could be a 2x out front. It could be a 3x out front. It could be a negative 3x out front. We don't know enough of that, but we're just creating some type of general factored form. We just go for easy point here of just saying it's going to be an x out front. That's always going to be the case when you've got a solution that is 0. It's going to be meaning that this was a GCF that was happening here. Okay. We'll do more work with it today, this week, and I know some of you that we'll just kind of keep talking out there. And we're going to do more with that here today in just a second too. Okay. Good question off of that. Anything else? You're looking back at things. Question there? Yes, Joanna.
I had a question on
14. 14? Let me see here. So, I'm sorry, the 14 was right there. So I think you trailed off on that last one. What was that last part you said? You keep trailing on.
It doesn't look the same as the assignment.
Doesn't look like the same as the assignment. I don't know. 20. That was yesterday, right? So 14. I don't know. Let's take a look. 14 right there. No, for some reason is it not. Okay, so 14 and that one is not definitely the same. So must have updated that one and for some reason not. So yeah, it's definitely not the same, is it? Don't worry about that, Brianna. Okay, don't worry about it. All right, just don't worry about 14. Anything else anybody's got besides ignoring 14? Then we'll get more practice. I'm not worried about that. Okay, make sure your name's on it. Throw it in the basket. Get out those notes. Let's do a few more here from the notes today. It's in factored form, isn't it? This one's good to go. Somebody's already factored this out for you. 2z minus 5, 2z minus 5. The biggest thing is it equals 0. Once you realize it's in factored form, you go straight to using your zero product property. You go and say each one equals, if I can write it, each one equals 0 and get your solutions. Like, there's nothing really to do with that one. It's in factored form. And once it's in factored form, that's where you want to be and get your 2 solutions. Now, I know several of us can do that in our head. Not several, everybody can do that in your head. Add 5, divide by 2, and z is what? 5 over 2, right? Now, when we've been working through this, we typically tell you how many solutions do we get. We typically get 2 solutions, right? How many solutions are we getting here? 1 solution. Because what is true about these 2 answers? They're the same, right? So in quadratics, I say typically you get 2 solutions because there are some exceptions to that rule. Here's an exception to that rule. This is a quadratic where actually we only get one solution. Do not tell me we get two solutions here. We are only getting a one solution, okay? 5 over 2. We're going to connect this to some graphing later on of why we also are telling you we're getting one solution here. But don't be surprised when you work things out and you realize, oh, deja vu. I get the same answer. You didn't do anything necessarily wrong. It's just that sometimes you can't get a single solution. And we'll connect it to the graph of it later on of where this is also coming from. So, yeah, we didn't do anything wrong there. We're good to go. Now, letter B, are you in factored form on letter B? No, we're not in any form at the moment. We're not even in standard form. So just like we did on the homework and like we did yesterday, when we weren't in standard form, you got to rearrange it, put it to 0. Rearrange it, put that thing to 0 by doing what? What do you got to do here? Yep, add 25x. As we add that 0 on over, sorry, not add 0 over, 25x over to set it to 0, there's one of our binomials. And then we talked about last week, when we have a binomial here, what type of binomial do you have? Where is that 0 located? Is the constant not there, or is the linear term not there? Because if the constant's not there, that makes you use the GCF. If the linear term's not there, it has nothing to do with the GCF. You go back to guess and check. So you got to realize, again, what's there, what's not there. A is 1, B is 25, and C is the part that's missing, right? So this has got to be your GCF, okay? Going through enough years of this, I've been really trying to emphasize over the last couple years all about that GCF, all right? So hopefully it's been paying off, so GCF it. And as you bring that out, I promise you on this one here, again, when that GCF is like this, one of the solutions will always be 0. The one that Chloe asked at the homework a few minutes ago, one of the solutions was 0. One of the solutions will always be 0. The other solution just depends on the problem. We bring out an x. What do you have left over? Take out an x, divide an x from both of those terms. You're left with x plus 25. Boom, we're in factored form. Just like letter A we started off with. With being in factored form, there's your two solutions. That GCF that you're bringing out front, that's going to get you that solution that's always 0 every flipping time. The other one, it just depends. The other one, it just depends on what the problem is. It's going to get you negative 25 in this instance. We're back to our typical two solutions. Okay, 0 is a solution. All right, 0 is a number, 0 is an answer. Okay, so we're back to our two solutions. All right, but we've seen that before. That's nothing really crazy off that. All right, let's flip. Let's take a look at a few other random things here. On solving, and on this, not random I should say, but just a few other ones here on solving. Okay, let's take a look here. Let's jump around here a bit. Let's go down 6A. 6A, let's do 6A. On 6A at the bottom, there it is. It's in standard form already from the get-go. And we go through our steps. It's in standard form. We do still look for a GCF to help our size of the numbers. 6, 25, and 4. Is there a GCF up there? No. So we're stuck. All right, guess and check it. So this takes us back to Friday, I think it was. A is 6, factors of 6. Factors of 6 are 1 and 6 are right. 4 is 1 and 4, 2 and 2. So here's where, again, the frustration could happen. If 1 and 6 doesn't work, it's going to be, 2 and 3. So you got to make sure you're checking either combination, and this is where the practice is coming into play. If you've been truly doing that work, Each day should get a little bit better for you. Keeping in mind the signs. What's going to be true about the signs here? Sames or one of each. Yep. It's got to be sames and they're both pluses. There's no negative at all up there. And then we got to get that up to a 25. All right. Getting that up to 25. And what's the combo that's going to work for you? 6x and 1x, I heard from Brianna back there. I would agree with her on that. And the 3x and 2x is never going to get you up to 25. And as you're trying to figure out that combination, as I'm up here working with you, that's the combination I'm working with in my head as well. 1 and 4, what combo works there? 2 or 2. 6x and 1x does it with the 1 and 4. 6 times 4 gets me up there pretty close. With the 1 helps me out. Now, don't stop there. Remember, we are going that next step. We're using your zero product property from yesterday. This is where a lot of students forgets the x equals 0, forgets we're solving. They stop there and they lose those last points. Please don't. Use your zero product property and get your 2 solutions. Now, from here, do you need to show me that step of setting each one to 0? I'm sure most of you are fine doing that in your head and saying, what are my 2 solutions? Negative 1 over 6. What's my other one? Yeah. Just don't forget to solve. Okay? All right. Nothing crazy. We did it yesterday. We're going to do some more work today, this week. Keep practicing it out. Let's take a look at a few other random ones on the back side that are decent ones. And on the back side, let's go with letter D. Okay? Let's go to the right there, letter D. Now, on the next one with letter D, as I throw these out here and as I talked about just come up wrapping things up, is letter D saying factored form? Looks like it. I got my parenthesis, but what does it not equal? It's got to be equal to 0 to be in factored form. What we just did on the other side, it looks similar to that, but this one does equal 0. What does letter D equal? Yep, it equals 2. That's not the same thing. So while letter D looks like, oh, this is a nice one, it's totally not. So what we have to do on letter D, and this one is a bit of a rough one, we have to distribute all that through, put it in standard form, and then factor. So there's like no shortcut here. Go ahead. You got to go the long way. We got to distribute that thing all through, put it into standard form, set it to 0, and then go through and factor this one. So as I see on letter D, I see on letter E, letter F, all those, they kind of look like, oh, they might be quick ones. Unfortunately, they're not. You're going to have to set that thing to 0 by distributing combined like terms, setting it to 0, which is not a big deal. It's just that, unfortunately, it's not a quick one. It's a little deceiving. We're pretty darn quick at this point on distributing and combining like terms. So just make sure you watch your signs. X squared starts it off. Like terms on the linears, 11x, negative 11x. And what does the constant turn out to be? Not 30, but 28. Now we're good to go. Now we're good to factor that. But you got to pay attention, what are you equaling? I have a lot of kids tell me my 2 solutions are 5 and 6, and they're done. That sucks because it's not good to go. It's not set to 0. Now we're good. Now you can factor factors of A, factors of C. And it's not going to turn out to be 5 and 6. I think it's going to turn out to be 4 and 7, I believe. 2 and 14, 3 no, and 4 and 7. Okay. So nothing major. Those are the SAT questions to watch out for. Okay, and these are not necessarily SAT questions, but these are getting into some problems with the next part of Algebra 2 as well. Set it to 0 and keep in mind my signs. Got to have the sames. It's a positive 28. So both negative. It's a negative 11. That's the only way to get that. And we're going to have to negative 11. 4 and 7. And again, once you're in factored form, I know most of you can just see that and tell me what my two solutions are. 4 and 7. Do you need to write it out and say x minus 4 equals 0, x minus 7 equals 0? No. But if you can definitely see that and get your two solutions, I'm more than happy with that. Okay? Watch those things out. Okay? Nothing crazy. Too crazy there at least. Okay? Now, same thing happens like on E and F. E, we're going to have to distribute that through. Same thing on F. Set all these equal to 0. Okay? Same thing on G. Not distributing it, but we have to just subtract 7x, and we're good to go. We've seen 7 enough times where I'm not going to run through that one. But I want to go backwards to the other page now. And let's take a look here. Let's do letter D. Okay? Letter D, and this will be our last one, I think, for today. Create me an equation that has those two solutions. So those two solutions, 3/4 and 7/4, what does it have to look like in factor form to have those two solutions? If I get a 3/4, what did it have to look like to be equal to 0? So undo that. 3/4. We just talked about that a few minutes ago. We talked about one like that yesterday as well. To be 3/4, it had to be first 4x, right? You had to divide by 4, you had to have 4x. And to be equal to 0, you had to have a minus, right? Minus 3. That's what we had to have, right? And you can always easily check it. If I add 3, divide by 4, I get 3/4, don't I? And on the other one, 7/4 gets me what? Same thing. Same idea. 4x and then minus 7. The only catch with this last one here is factored form is what I started off with you guys yesterday on. Now put it into standard form. Know your vocabulary. Know which one looks like which. Okay? Here's my factored form. That's what we've been focusing on. We want to be in. Now read it. We also want to put it into standard form. So what does standard form again look like? Distribute off to the side, bring it back in, and put it into standard form. As you roll it into Algebra 2 next year, you're going to be going back and forth between factored form, standard form, and a third one out there. I don't know if we'll get to it with you. Vertex form. We have 3 major forms. You'll just go back and forth all between. Knowing those, at least 2 out of 3 forms like that, you'll be hitting the ground running next year. Great. Standard form, distribute on through. 16x squared, 28 and 12. What is that? 40x, I think. Somebody get a 40 on the linear. Check me. And a plus 21. Always please check me, but I think hopefully that's about right. But all I did was distribute combined like terms, which we've done a crap ton of those over the last week and a half. Okay? But nothing major. We did our last big twist on factoring. So those are the last major twists that we now are doing on our factoring skills. There are a couple more things out there. I don't know if we'll get to all the major things, but we've done 95-ish% of the factoring we need here. And you'll be more than set for helping yourself out for next year too. So now we want to keep getting good at and great at it. And we're going to keep adding on to it by connecting some things with graphing to for next week. In order to do some graphing for next week, I gotta do some prior knowledge skills before I do graphing with you. So then tomorrow